Imagine Arizona, a land of stark beauty sculpted by wind and time. But not as we know it. Erase the arid landscape, the cacti, and the sun-baked earth. Journey back 209 million years ago during the late Triassic period. A time when the world was vastly different. The air is thick and humid, heavy with the scent of unfamiliar vegetation. A constant warm moisture hangs in the air, the sun blazing over a lush tropical floodplain teeming with life. A vibrant ecosystem stretching as far as the eye can see. Great rivers wind through forests of colossal horsetails and towering cycads, their fronds creating a dense green canopy. A world far removed from the desert landscape we see today. A transformation almost beyond comprehension. This land sits near the equator, on the edge of the supercontinent Pangaea, a single massive landmass dominating the globe, alive with the rumble of distant volcanoes. The Earth is restless, still forming and shifting. Volcanic ash settles over everything, a constant reminder of the planet's raw power. Preserving the secrets of this era for millions of years, a snapshot of a world in transition, captured in stone. Life here is flourishing after a catastrophic extinction, rebounding with incredible speed and diversity, with new forms constantly emerging and evolving, filling every available niche. A biological explosion is underway. Armored fish fill the rivers, their scales glinting in the sunlight filtering through the dense foliage, while primitive amphibians chorus along the muddy banks, their calls echoing through the humid air. The old reptilian rulers still dominate, but their reign is being challenged. But new challengers are appearing, experimenting with flight and new ways of living. The seeds of future dominance are being sown. Above the forests, a remarkable sight, a glimpse of the future of evolution. A vertebrate has claimed the sky for the first time. A pivotal moment in the history of life. This is not a bird or a bat, those would come much later. But a pterosaur, a flying reptile, a pioneer of powered flight, a creature perfectly adapted to its aerial world. Its fossilized remains, hidden for eons beneath layers of sediment, are about to reveal a profound chapter in the story of life on Earth. A chapter written in bone and stone, waiting to be read. For millions of years, the story of this ancient flyer lay dormant, a secret whispered only to the stones. The very landscape held its breath, waiting for the right moment to reveal its hidden past. Encased in volcanic stone, a testament to the cataclysmic events that both preserved and concealed it. The layers of ash and sediment acted as a time capsule, safeguarding this relic of a bygone era. The lush Triassic floodplain, teeming with life and vibrant with vegetation, eventually transformed into Arizona's Petrified Forest, a silent monument to time's relentless march. A fossil-rich landscape where every stone holds the potential to unlock secrets of the past. It's a place where the echoes of ancient creatures still resonate. Here, a dedicated team led by Ben Kligman, driven by curiosity and scientific rigor, uncovered a paleontological puzzle, a challenge that would rewrite our understanding of early flight. Fragments of a pterosaur, a creature that once soared through the skies of the Triassic period. These pieces of bone held the key to unlocking a chapter in evolutionary history, including a delicate jaw, a testament to the fragility and resilience of life. This jaw offered clues to its diet and lifestyle, fangs, sharp and formidable, and the signature wing bones, the very structures that allowed it to conquer the skies. These bones spoke of adaptation and survival. These remains were found among fossils of at least 16 vertebrate species, a diverse community of creatures that shared this ancient world, 7 new to science, adding to the richness and complexity of this prehistoric ecosystem. Each new species offered a glimpse into the intricate web of life that once thrived here, painting a vivid picture of a lost ecosystem, a vibrant and dynamic world teeming with life, now brought back to life through careful scientific investigation. The discovery, announced in July 2025, sent ripples of excitement through the scientific community, capturing the imagination of researchers and enthusiasts alike. Was named Eotephradactylus mcintireae, a name that would forever be etched in the annals of paleontology. Dawn Ashfinger, a fitting tribute honoring its ancient age, its volcanic tomb, and a key park volunteer whose dedication helped make this discovery possible. At 209 million years old, a staggering span of time that dwarfs human history, Eotephradactylus is the oldest known flying reptile in North America, a landmark discovery that rewrites our understanding of the continent's prehistoric past. And among the oldest worldwide, placing it among the pioneers of flight in the early days of pterosaur evolution. It pushes back the timeline for pterosaurs on this continent by millions of years. forcing scientists to reconsider the origins and dispersal of these magnificent creatures. This fossil is not just another specimen, it's not simply a bone in a museum collection. It's a critical clue to the dawn of vertebrate flight, offering invaluable insights into the evolutionary journey that led to the skies being conquered. Eotephradactylus gives voice to a forgotten world, allowing us to hear the rustling of ancient forests and the calls of long-extinct creatures, reshaping our understanding of early flight, challenging existing theories and opening up new avenues of research. Its discovery echoes through the halls of paleontology, resonating with scientists and enthusiasts alike, rewriting what we thought we knew about the origins of flight and the history of life on Earth. Reconstructing Eotephradactylus from fragments is a blend of science and imagination. This was no giant, about the size of a small seagull with a wingspan of 3 feet. Its skull, 4 inches long, was armed with curved fangs for snatching prey and blade-like, tricuspid teeth for slicing. This dental arsenal marks it as a versatile predator, able to tackle a range of small animals. Eotephradactylus had a long, bony tail, likely used for balance and sharp turns in flight. Its body was light, covered in fuzzy pycnofibers for insulation, evidence of warm-bloodedness. The wings were marvels of engineering, a membrane stretched from body to an elongated 4th finger, forming a living sail. The other fingers were short and clawed, perfect for climbing or perching. This unique anatomy made Eotephradactylus a true pioneer of the prehistoric skies. Pterosaurs were the first vertebrates to master flight, and Eotephradactylus shows us how. Its bones were hollow and air-filled, making the skeleton incredibly light. Powerful chest muscles anchored to a strong breastbone drove the wings, generating lift. The wing membrane, reinforced with actinofibrils, allowed precise control and agility in the air. Early pterosaurs likely launched into flight using all 4 limbs, vaulting themselves skyward. Once airborne, they soared on thermal updrafts, scanning for prey below. The long tail provided stability in steering, especially at low speeds. Flight gave Eotephradactylus a huge advantage: escape from predators, access to new food sources, and the ability to travel far. By 209 million years ago, pterosaurs like Eotephradactylus were already sophisticated aerial acrobats. The teeth of Eotephradactylus reveal its role as an aerial predator. It hunted above rivers and wetlands, using its curved fangs to snatch fish or amphibians with swift, precise strikes. Skimming low over the water, it could grab prey without landing, using energy-efficient tactics. The blade-like teeth at the back of its jaw sliced prey into swallowable pieces. This dental toolkit made it a specialized and efficient hunter, exploiting a unique ecological niche. Beyond rivers, it may have perched in trees, launching ambushes on lizards or insects below. Its versatility made Eotephradactylus a master of both air and water's edge. In a world full of danger, it thrived as a nimble, adaptable predator. Eotephradactylus was part of a vibrant community, preserved by volcanic ash in stunning detail. The rivers teemed with primitive frogs, early turtles, and crocodile-like phytosaurs. Armored Eotosaurs browsed the lush banks, while giant ferns, cycads, and horsetails dominated the landscape. Petrified conifers, now stone, once towered over this ancient forest. This dense vegetation fed herbivores and sheltered smaller animals from predators. The Triassic was a time of recovery after Earth's greatest mass extinction, with life diversifying to fill empty niches. Old lineages coexisted with new, creating a dynamic, ever-changing ecosystem. Volcanic eruptions both threatened and preserved this world, turning it into a paleontological treasure chest. The fossil record here captures a pivotal moment: life rebounding and experimenting after catastrophe. Eotephradactylus's world was a lost Eden, both alien and strangely familiar. Pterosaurs were the first vertebrates to achieve powered flight, long before birds or bats. For years, their origins were a mystery, with the oldest fossils found in Europe and already fully adapted for flight. Eotephradactylus, at 209 million years old, is among the oldest pterosaurs ever found, and the earliest in North America. Its presence shows that pterosaurs had already spread globally by this time. This fossil pushes back the North American timeline by 15 million years, filling a crucial gap in the pterosaur family tree. Comparing its features with other early pterosaurs helps scientists trace the evolution of flight. Eotephradactylus offers a rare glimpse into a world on the brink of monumental change. The Petrified Forest ecosystem, a landscape frozen in time, was a fascinating crossroads. Imagine a world teeming with life where ancient giants roamed alongside creatures just beginning their evolutionary journey. It was a meeting point of ancient and emerging life, a vibrant tapestry woven with threads of the past and hints of the future. This unique environment fostered a blend of species, each playing a crucial role in the delicate balance of the ecosystem. Old reptile lineages, once dominant and unchallenged, found themselves sharing the stage. They mingled with the ancestors of modern frogs, those resilient amphibians that have hopped through millennia. These early frogs were adapting and evolving, carving their own niche in this ancient world, and turtles, those armored reptiles with their slow and steady approach to survival. Eotephradactylus itself was a symbol of innovation, a testament to the power of adaptation. It was an early flyer, testing the boundaries of what was possible, in a world not yet ruled by dinosaurs, a world where the skies were still open for new contenders. The largest land predators and herbivores were not dinosaurs, they were something else entirely. Instead, other reptiles like the heavily armored Pterosaurs with their tough hides and formidable presence dominated the landscape. And the Phytosaurs, those crocodile-like predators lurking in the waterways, added another layer of complexity to this ancient ecosystem. This unique mix of creatures shows that the late Triassic was not a simple, straightforward march toward dinosaur dominance, as we might have once believed. It was instead a period of intense competition, a struggle for survival in a rapidly changing world. And remarkably, a period of coexistence, where different groups of reptiles managed to share resources and carve out their own ecological niches. Volcanic ash, a byproduct of the Earth's restless activity, paradoxically enriched the soil, fueling lush plant growth, creating a vibrant and verdant landscape. This abundance of plant life in turn supported a complex food web, with herbivores feasting on the vegetation and predators preying on the herbivores. Yet, this same geological activity, the source of life-giving nutrients, was also destructive, a constant reminder of the Earth's immense power. Ultimately, it led to another mass extinction, a catastrophic event that reshaped the course of life on Earth. This extinction marked the end of the Triassic, a pivotal moment in geological history. Many old lineages, those ancient groups of reptiles that had thrived for millions of years, vanished from the face of the Earth. This cleared the way for dinosaurs in the Jurassic, ushering in a new era of reptilian dominance. The world of Eotephradactylus was a fleeting, vibrant moment, a snapshot of life on Earth before the dawn of the dinosaurs' long reign. It was a brief period of relative stability before the next great upheaval, the next dramatic shift in the Earth's ever-changing story. Its fossilized remains, preserved in the rocks for millions of years, capture a turning point, a critical juncture in the history of life. They offer us a glimpse into Earth's evolutionary story, a story of constant change, adaptation, and resilience. The most intriguing aspect of Eotephradactylus's world is what's missing: dinosaurs. Despite a rich diversity of vertebrates, not a single dinosaur bone was found at the site. This challenges the idea that dinosaurs quickly dominated every environment after their appearance. Early dinosaurs may have been rare or restricted to other habitats, while established reptile groups thrived here. The absence of dinosaurs raises questions about competition, climate, and chance in shaping ancient ecosystems. Eotephradactylus's discovery answers some questions about flight, but opens new mysteries about the rise of dinosaurs. Each new fossil brings us closer to understanding the lost worlds of deep time.